Hello, dear customers, dear partners, ladies and gentlemen. Great to be able to welcome you again for today's webinar. Good morning, good afternoon, wherever you are in this world. It's fantastic to talk to you again. My name is Alexander Weicker, and I'm CEO of Vexel Imaging. For today's webinar, which is all about UltraMap version 4.5, we have two speakers. Myself doing the introduction, and then Bernhard Schachinger, who is in the photogrammetric department of Vexel, will join us later and will talk to you about all the exciting new features we have implemented into UltraMap 4.5. So let me start with an overview about the general workflow. Then Bernhard will talk about the features of version 4.5 in a greater detail, and then he'll also run a live demonstration of the new software, and later we are opening up the floor for Q&A session. So that's what we have prepared for today. And now let me open the window of UltraMap version 4.5. Just to recap a little bit, for those who are not so familiar with the UltraMap workflow. The UltraMap workflow is an integrated software solution dealing with UltraCam imagery, and it consists of several modules. It all starts with UltraMap Essentials, then it goes to UltraMap AT, then the next step in the processing chain is the UltraMap Dense Matcher, followed by the Ortho pipeline, and last but not least, we have the UltraMap 3D TIN module. I'm now zooming a little bit into the details of that workflow before I hand over to Bernhard. So UltraMap Essentials is the first step in the UltraMap processing workflow. This is the module which is required in any event if you want to process UltraCam imagery. So in this module, a camera calibration is applied. Any real-time data collected by the sensor, real-time metadata of the camera, like the measurements of the embedded temperature sensors are applied. The stitching is done, the image registration is done, and also the data structure for the whole UltraMap processing chain is being prepared, defined, and set up in the module. Also, very important in Essentials, we have a very rich feature set for radiometric. So all the radiometric steps are also applied and performed in the Essentials module for all the products, like for the PAN images, RGB, RGBI, CIR images, and so on. Big and important feature here is the automated color balancing, removing a lot of manual work. But then if you want, you can also fine-tune with manual adjustments to optimize individual images or a whole block. So that's also done in UltraMap Essentials. And from there, imagery can be exported to go into other software systems. But of course, you can also continue staying in the UltraMap flow, which then means you can either export or you continue with the next module, which is the UltraMap AT module. So in the AT module, you can perform all these features which are needed for professional area triangulation. So you can merge multiple flight missions. You can deal with images. If there are duplicated images, they can be removed. You can import ground control points, checkpoints. You can deal with the GPS data. So everything which is necessary for AT. And once you have loaded in all these informations like GPS, like ground control, and so on, then you have a highly interactive, very, very intuitive workflow supported by a lot of graphics. So first of all, Typepoints are being extracted automatically. You can modify weight on Typepoints. You can add or you remove. Then when your Typepoint structure looks nice, you can run the bundle adjustment. Results are being visualized. You're getting reports. You're getting night graphic to give you a deep insight into the quality of the AT. And then as a result of the IT, the exterior orientations are exported together with a related report. In the dense matching module, UltraMap generates a 3D, so a set value to each pixel. That is done by a dense matching of the stereo images, multiple pairs. So as a result, we have a point cloud, we have an automatically generated digital surface model that of course can be visualized, it can be edited, so to fine-tune or to remove artifacts. Automatization is never perfect, it works great, but there's an editor so that you can deal with artifacts, and then the surface model can be exported as well as a point cloud can be. Once that is done, the imagery and the surface model are combined in the next step, which is the ortho pipeline. And here we are projecting the images on the surface model, which gives a DSM also, or we can also use the internally generated terrain model. It's also part of the UltraMap workflow, do the projection to derive a very classical DTM ortho imagery. Seamline editing is also part of that module, and then of course you can export the mosaics together with the seamlines. Or next step, you stay in the UltraMap workflow, jump to the 3D module, to the 3D tin module, and in this module, a 3D mesh is automatically generated from the point cloud, and it's visualized in UltraMap. And then, of course, once the 3D tin has been generated, it can be exported in various file formats so that you can use other software systems to continue working with the 3D tin, which has been generated. Although not only the 3D tin by itself, but also the tiling scheme. So you can play around with several export parameters to make it best work for your downstream software processing tools. When we look on the combined workflow, each step of the UltraMap workflow allows to export the data in standard file formats so that you can use or can continue your work with other software systems. But there's of course a tremendous benefit if you stay inside the UltraMap workflow. It is an integrated software solution consisting of several modules. When you stay in the workflow, you have this automated setup of the project files. Camera calibration parameters are applied in the correct way. The whole data structure inside UltraMap is optimized for the whole workflow, for a fast interaction, fast GUI, zoom in and out, smooth and fast, and so on. And when you stay in the UltraMap workflow, you also don't need to deal with a ton of exporting and importing feature, which is time consuming, or can reduce data quality, or can add other mistakes, and so staying in the workflow is fast, is intuitive, and highly efficient, and also all the modules benefit from the underlying distributed processing, which is a highly sophisticated feature in UltraMap, where you can very flexibly use your network structures for the utmost speed of processing. So, and that brings me already to the end of my introduction. I'm now happy to hand over to Bernhard Schachinger, and Bernhard Schachinger will do now a deep dive with you into the features of UltraMap 4.5. So I wish you great pleasure with Bernhard, with this part of the presentation. I'm looking forward to meet you later for the Q&A session again. Thank you very much. See you soon again. Bye.
Thank you, Alexander, for this nice introduction, and hello to all of you, and welcome to my part of this webinar now. I'm happy to give a little overview of the new features in UltraMap version 4.5. So our main focus was on improving the image geometry. For our third generation cameras, so that's the UltraCam Eagles, the Osprey, and so on, we have now available the accurate camera modeling feature, so-called ACM, which is replacing the temperature dependent modeling which we had before. So this feature, this is relevant for processing the image raw data, the level 0 data, to level 2. And this new feature is handling the temperatures in a much more sophisticated way than the TDM was doing. For the first and second generation cameras, we still have the TDM algorithms implemented, but we did significant improvements there so that image geometry is also enhanced now with the new UltraMap version for these older generation cameras. The new enhanced image geometry has a beneficial effect on error triangulation quality and on all the products that are derived from the error triangulation results. That means all measurements in stereo, DSM, orthophotos, 3D mesh, and point cloud. Then we have added full support for oblique images to the error triangulation module. So now we can automatically collect type points in nadir and oblique images. We have added measurement functionality for ground control points, checkpoints, and also for manual type points in nadir and oblique images. And all of these measurements, the automated measurements and the manual measurements, they can now be combined in one bundle adjustment run to have all viewing directions consistently being adjusted in one solution for best possible geometric quality of the output. We have a few additional features in this new software version. So first is that we have now a type point thinning implemented. This type point thinning allows to reduce the number of type points in your error triangulation block, and this is freely configurable, so there are several parameters available in the interface for you to control the thinning process. And further down in the workflow, we have improved the application of Earth curvature and atmospheric refraction correction for the processing of the DSM, the orthophotos, and the 3D modules. These improvements result in much clearer and sharper edges of buildings and therefore better quality in all the products that you can generate. Besides these features, there are a number of bug fixes and smaller improvements which will also be hopefully of nice help in the daily work. So let's switch over to the live demonstration.
Yeah, for this live demo we have prepared a few datasets to demonstrate the new features of UltraMap version 4.5. So this dataset here is from Melbourne in Australia and was captured with an UltraCam Osprey Mark III. These blue symbols here show us the shot positions of the east-west flight lines. The first new feature we are going to look at is the Typepoint collection. So right click here and then select Submit Typepoint collection from the context menu. First I select the process destination, and then we see here three new parameters in this dialog window. The first parameter, the image selection, this defines all the images that are selected from the dataset for the processing of the type point collection. So these are all the images where type points are going to be extracted. There are three settings available. The first one, nadir and oblique subset. That means that the software is taking all the nadir images plus additionally all the oblique images at the project border and all the oblique images from capture events where the nadir image does not have a very well linkage. And in addition, a number of oblique images are selected inside the project area, and these are used for the type point extraction as well. The second option for this parameter, nadir and oblique, that means that all the nadir images and all the oblique images are taken for the type point extraction. And the third option here is using nadir images only for the typepoint extraction. So the difference between the first two options here is mainly the processing time. So if processing with oblique subset, there is a significant reduction in processing time comparing to the second option with using all the oblique images for typepoint extraction. The second parameter here, the size of the oblique subset, this allows to define the number of images that are selected by the software distributed across the project area. So a low number here tells the software to select a low number of oblique images inside the project area. Therefore, this will speed up the processing. A high number here will tell the software to select more oblique images, and therefore it will require more processing time to extract the type points. And then the third parameter, the minimum image overlap for matching, that is a parameter which tells the software what candidates can be matched or what candidates of image pairs can be used for feature matching, for looking for type points to connect the image pair. So the software is trying to automatically do some analysis of the data, calculate the overlap, and then predefining these values, but at any time when submitting the typepoint collection, this parameter can be modified. And the fourth option here, rely on precise post-processed GPS IMU data. That is unchanged from previous UltraMap software versions and behaves exactly the same like before. Now let's have a look at the results of this typepoint collection. This view shows us now all the type points that could be extracted for this project. The type points are color-coded. The dark green colors represent low elevation of the points, and brighter color tones, the brown and the yellow, they show higher elevation of the points. So in the city center with the tall buildings, we have points at higher elevation. The link diagram gives very important feedback about the typepoint collection. So the lines in this diagram, they show image pair combinations that have type points in common, so image pairs that are linked by type points. The color of these lines tells us about the number of the type points between an image pair. So the green color means there's a very robust linkage. Yellow or orange color means there is a lower number. In this southwest corner of the project area, we see that there are orange lines. Therefore, let's have a look at the image content. So selecting a few of these images for display, we see there is a lot of water, a little bit of beach, and then urban area. There was not enough image content to extract all the type points. However, these images here, although they are almost fully over water area, they are very well connected to the other images. The reason for that is now the new typepoint collection of UltraMap takes advantage of the oblique images. So these oblique images that are activated now for viewing, they are used in the typepoint collection. So now activating the measurement view. So now in this view, we see for these capture positions the typepoint measurement race in the nadir viewing direction, which has only a very, very low number of type points, but showing these images, we see that they connect very well via the oblique views. To show you the benefit that the new processing of combining nadir and oblique images brings to the overall result, we have prepared another version of this dataset where we processed only the nadir images. So activating the diagram for this version of the dataset, we see in this southwest corner of the project that there are a lot of red lines, and a few images they are not even connected to any of their neighbors at all. So that means using nadir images only, we could not extract any type points here because of the water. Switching back to the combined result for nadir and oblique viewing directions, we see the very well connection of all the images. The next feature I would like to show is ground control point measurement. So for that I switch to another data set captured in Graz with the UltraCam Osprey, and here I switch off the display of the type points so that we can see these ground control points, the triangular symbols, a little bit easier. Then I double click one of these points and the measurement window for the ground control points opens. This window here opens per default with a zoomed in view to one of the images where the estimated position of the ground control points is as close as possible to the image center. But when zooming out, we can see all the images where this point would be visible and could be measured. Besides the visual display of all the images with the estimated position of the ground control point, there is also a list with all the images that see this point. So in this list here in the Data Explorer, we can see all the images in the nadir viewing direction and the oblique viewing directions, which would allow to do a measurement for that point. So in the display, all the crosses, they are now red, which means that not yet any measurements have been done. I can double click on any of these images here in the list, and the software zooms in to this image to the estimated position. I can then drag and drop the cross to do the measurement. The color turns green, which means that this measurement has been now done in a manual way. Using the arrow keys on the keyboard, I can then jump from one image to the next to do some measurements there. While jumping from one image to the next here, we see that in the Data Explorer in the background, the software is highlighting the image that is currently active for the measurement. The measurement of points works in exactly the same way for ground control points as we see it here. Also the same for checkpoints, and also the same for manual type points. Based on the measurements that the operator has already done, the software tries automatically to complete some measurements in the other photos. These measurements that could be done by the software in an automated way, these are highlighted by the blue color of the cross here in the display. So zooming out, we see that there are already a few blue crosses which could all be completed by the software. Also looking here in the list in the Data Explorer, we also see there the information about the measurement mode which was automated for these points. So after ground control point measurement, the next step in the workflow would be to do a bundle adjustment. So I close the measurement window, then right click, and in the context menu I select bundle adjustment here. The first new feature is here options to select if the bundle adjustment should be processed on the local machine, or if the bundle adjustment should be submitted to the UltraMap framework as a processing job. The reason for that is that for large data sets, a bundle adjustment can be quite resource consuming. Therefore, it might make sense to have a dedicated machine on the framework to run the bundle adjustment jobs. For this demo, let's run the bundle adjustment on the local machine. So the first parts here of the bundle adjustment dialog window, they have not been changed at all. But here in the Advanced tab, we see that there is a new parameter available for the project optimization. This parameter is relevant for the oblique sensors. So if this is activated, then the software tries to optimize the translation and rotation from the nadir projection centers to the oblique projection centers based on the project data. The new values are then reported in the output files. If this parameter is deactivated, then the eccentricities from the laboratory calibration are used in the bundle adjustment. So let's run this bundle adjustment now, and then let's have a look at the results. Okay, so the bundle adjustment is finished. Let's double click on this bundle adjustment result in the navigator, and then we can open the report. We have added now some additional information in the error triangulation report for the oblique images. The first page in the report is an overview page giving some general information. So here, for example, we have added the mean photo scale for the oblique images. Then we have added here a few lines for the image observation errors in the oblique images, grouped by the type of points that are being measured. So this is reporting values in a separate way for type points, control points, and checkpoints. Then on the next page, there are a little bit more details given. In this section here, image observation errors, we have then these errors being divided into the single viewing directions of the oblique camera cones. So for example here, all the measurements are summarized from the left looking camera cone. Of course, the data can be exported to some standard file formats, so for example to a bingo project file, and then this data can be used in third-party software for doing further analysis and further processing. The next step in the UltraMap workflow would then be to process the color balancing. If you're going to process the color balancing and go on in the UltraMap workflow, then you do not need to worry about how to handle the results of the error triangulation, how to transfer that to the next step. All that is done fully automatically by the UltraMap software, so all the results from the bundle adjustment, they are transferred to the color balancing processing as well as the data, so there is no need for importing or exporting any data and for doing any time-consuming project setup. Another new feature I would like to show is the Typepoint thinning. So in this dialog window, we have two parameters to control the thinning process. The first parameter here, apply distance threshold. This tells the software when to terminate the thinning process when this distance here in between the type points is reached. And the second part of the interface, this allows to define sections for the images. So every single image is divided into these sections. In our case here, 9 sections in total. I can then apply a number of type points for each single section, and the software will then do the thinning process as long as then this number here is reached. So with that interface you can fine-tune the imagery, the type points to fit to your project requirements. So let's start this thinning process. More than 200,000 type points have been removed in our case here for this data set. And now looking at the view of this project area, we see a very sparse distribution of type points. So the last major new feature I'm going to talk about is the enhanced handling of Earth curvature and atmospheric refraction correction. In combination with all the enhancements that we did related to image geometry and air triangulation processing. So that means the new ACM, the improvements for the TDM, and the improvements in the air triangulation workflow, all that brings benefit to the products down the road in the workflow. So to the DSM and the orthophoto, the 3D mesh and the point cloud. To show that, I switch to the ortho application and activate the DSM that we have processed for this dataset. And zooming in, we now see very sharp edges and very good geometric quality of this DSM. All these improvements in the geometry, all these improvements in the DSM, of course, have a very positive effect on the quality of the orthophoto. So let's switch back to UltraMap Studio to have a look at the quality in the 3D mesh with these new improvements. So in this center part of the AOI, we have processed a few tiles to the full resolution 3D mesh, which is loading here right now. The improvements in geometry bring benefits to the reconstruction of the roofs and the facades, so that a lot of details are then included and the textures are very well applied to the facades. So with that overview of the 3D mesh, I would like to finish this little live demo, and we are now happy to answer your questions. Thank you.
Hi everybody, this is Alex again. Hey, we are done with the first part of the webinar, or let's say the first two parts of the webinar, and now we are entering the question and answer session. So there is a Q&A area in your screen. Please be so kind and type in any questions you might have. Bernhard is with me, and Bernhard and myself, we are happy to answer as best as we can. Okay. All right. So the first question is: somebody wasn't able to view the whole webinar. Question is: will it be recorded and uploaded for viewing afterwards? Answer is yes. We have recorded the webinar, and it will be available for download afterwards for the registered participants. All right, so now it goes into technology. Chris has some questions around AT, how it looks like. With that, I'm handing over the mic to Bernhard and ask him to answer this set of questions.
Yeah, so this question is related to the connection of nadir and oblique images over water area and such. Yeah, our interface for viewing the air triangulation results that supports the operator to identify images that have weak connections. And this interface, it works for nadir and oblique images. You will be able to see these images in a very easy way. For example, also using this visualization of the measurement rays. And with using that, you can select single images you think that are not that well connected to the block. You can delete them, or alternatively, you do not need to delete those images from the block, but of course you can measure manually type points to link these images to the block if you need to. But we do not expect that the number of images that need additional type points will be high, as the type point collection has now a new approach, which is an iterative approach. First iteration is extracting type points, then the software is checking if there are any weak areas, and then there is another iteration and so on. So with that, we hope that there will be a very robust Typepoint collection available in the end. So the next question is related to the Typepoint filter. So the filtering algorithm, it tries to retain the Typepoints with the high number of connections, of course. So we have a few criteria for the filtering to make sure that the Typepoints which are most relevant, most useful for the entire block do survive the thinning process and are used for the final solution. So the next question is regarding the system requirements. We have detailed information on the system requirements for the UltraMap servers for processing and the UltraMap front-end machines in our release notes. It's basically Windows operating systems, starting with Windows 7, then we are supporting Windows 8 and Windows Server operating systems. For the processing on the backend machines, we require Intel CPUs and NVIDIA GPUs if the GPU processing option is activated. On the front-end machine, it's quite flexible what kind of hardware we use there or we require there. But for the details, I recommend to have a look in the release notes of the software. You will find all the information there. So the next question is regarding results of a data set that was captured with a nadir-only camera. Yeah, for nadir-only cameras, this new software version does not bring very big differences. I would say one of the big major differences will be in the processing of the raw data from level 0 to level 2. So in that step, we have now the new ACM for third generation cameras. And for the first and second generation cameras, we have the improved TDM. So this is now a new generation of the software for the image post-processing, and all these improvements, they have an effect on the image geometry. Image geometry, that means you will get a better quality result in error accumulation, and then also in all the following products, starting from the DSM to the orthophoto and the 3D mesh. So the next question is regarding how is ACM working in detail. So a few new features are implemented with ACM compared to TDM. ACM is using information from a number of temperature sensors within the camera. So TDM is using the readings from one temperature sensor. ACM is using a number of temperature sensors. Then, in addition, we have with ACM a new modeling of the behavior of the lenses of the camera. And finally, with ACM, we are using refined factors and parameters to model the changes in the materials being used within the camera with changing temperature. So these are the three main components of ACM. There's this question for what type of system specs do you recommend for this software? I guess that is related to the hardware requirements for being used on the front-end machines and on the back-end machines. So that is related to the question we had already earlier. So I would say details for that, best have a look in the release notes, and here you will find all the information. Yeah, the next question is there any educational version for its use in our practical classes at the university in Spain? How much is it? For this question, I hand over the microphone to Alexander.
All right, so the answer is yes, there is an educational version available for universities. The specific the specific price depends a bit on how is it used and how many and so on. So please be so kind and contact us by email. Let's talk, and then we are happy to make you a very good offer on an educational version. Thank you very much.
So the next question is regarding the 3D point cloud and the quality, also regarding the noise. Yes, so with the new version, there is definitely an improvement in the 3D point cloud. So with all the enhancements, starting from the image post-processing to the error triangulation processing, and then the enhanced earth curvature and refraction correction, we get now clearer edges, better reconstruction of the details in the DSM, in the point cloud, and in the mesh. And this also finally results in nice texturing of the tin in the end, with now very nice details on the facades and straight lines for the windows and so on. So the next question is regarding if we are using two cameras at the drone to capture the images, one for the NADA and one for the oblique images. So we are using the data from our UltraCam cameras. And the UltraCam Osprey, this is our camera model for simultaneous nadir and oblique image capturing. So this is one camera which has the camera cones for all these viewing directions integrated. And we need only one flight to capture nadir images in the panchromatic channel, RGB channel, and near infrared, plus the oblique images in RGB. So the next question is about the enhanced resolution in the error triangulation process. Because with activating that option, the pixel size and dimensions of the images change. Yeah, so if this tool, if the enhanced resolution is activated, then we take care of that throughout the entire workflow. And of course, use change the pixel size and dimensions throughout all the steps in the workflow, and also for all the export steps. Yes, so the next question is again regarding the Typepoint thinning process and which points to keep. Yeah, so as we have demonstrated, there are basically two parameters for the user to control the thinning process. On the one hand, you can specify a distance in between the points. On the other hand, you can define sections for the image area, and then tell the software the number of type points for each single section that should be available after the thinning process. And then the thinning itself, it needs some decision criteria for type points to select, which should survive the thinning process or which type points should be eliminated. And among these criteria is, for example, the number of measurements. So how many images do see one of the type points? Then, of course, reprojection error and some other information. Yeah, the next question is regarding ACM. If ACM requires updated camera operating software. Yeah, for best quality of the workflow of the data, you will need the latest version of our hardware. That means third generation cameras with hopefully all the updates, and then it also makes sense to have the camera calibration and the camera operating software being updated to the latest version to benefit from all improvements that we offer in the workflow, including ACM. Then for nadir and oblique AT result, can it be exported for processing the 3D modeling context capture? Yes, of course, data from every single step in the UltraMap workflow can be exported to be used in any other software for any other workflow. So the error triangulation result can be exported to several formats to be used then in third-party software. So the next question is regarding the header of the file of the level 3 RGB images. So I do not have information now exactly on the background for this question. I do not know exactly what is the problem we should correct here. Of course, we did a few improvements. Of course, we tried to correct any things we got reported in the past. So several bug fixes are included in version 4.5, and I hope this one here is also being solved. Yeah, so you could send us that question via email, and we will then check in detail and then come back to you. So the next question is regarding output formats for the 3D mesh. So for the 3D mesh, we have several file formats available to export. So we provide export to OBJ format, to OSGB, LOD3 export, and we allow to export a point cloud which was derived from the mesh in LAS format, including colors. So the next question is about the workflows. Are there separate workflows for oblique and nadir cameras? No, UltraMap is a system which allows to combine all our cameras. You can process data from the nadir cameras and also process data from the obliques. The software tools are exactly the same. The workflow is the same, and it requires no separate handling of the data in any of the stages in the workflow. So it's a very consistent workflow and highly automated for both types of cameras. Next question is, true auto option still available? Yes, we still support processing of the DSM, and based on the DSM, the true orthophoto processing. So there is the question, what is the accuracy level you can achieve for the oblique images in the new workflow? So with this new workflow, with the new error triangulation environment, we can provide oblique images at an accuracy level being very close to the nadir images, with differences in the reprojection error in the subpixel range. Yeah, the next question is about the integration of data from other sensors to improve the 3D mesh model, such as LiDAR. So right now at this point, the UltraMap workflow is relying fully on the data from our cameras. So we can fully process the data from nadir cameras and the obliques using that, taking advantage of all the viewing directions. But right now we do not support data from any other sources for the 3D mesh. We will investigate, we will see if that makes sense then later on. Yeah. So next question is again regarding the 3D mesh. Is there any workflow that allows editing of mesh geometry externally, then re-importing to allow retexturing? Right now, we do not support this workflow, but yeah, we have ideas to support somehow editing of the 3D mesh. So let's see what the next versions will bring. The next question is regarding the Earth curvature correction and which parameter controls that. So Earth curvature correction and refraction correction, these are parameters, or these are options that can either be activated or deactivated in the bundle adjustment. And besides activating or deactivating, the user can enter the Earth radius. So that means with the Earth radius value you want to use, you can control this parameter. So depending on the piece of literature you are using, you might want to enter some alternative Earth radius value, or you want to do the processing either in meter or in feet. Then you can also use that with entering the number in this field for the Earth radius. There's the question, how do you get this new version? For that, I hand over the microphone to Alexander.
Okay, so in general, there are two ways how you can get UltraMap. So we are offering a subscription module where you subscribe into one or multiple modules of UltraMap for a defined time. And the other way to own UltraMap is a standard purchase where you buy your set of UltraMap modules of a given license. When you are under subscription module, any update is part of the subscription module. So you get all the updates, like the update to version 4.5 for free as part of your subscription. Just ping us and we'll get you the latest version. If you have purchased UltraMap version, there are two options. If you have a software support package, then the upgrade is covered by this software support package and you get it as part of the maintenance you have with us. So again, also here, when you're ready to upgrade to the latest version, ping us, you get the files, and then you can enjoy the new features. When you are not under maintenance, then please talk to your sales representative of Excel, and he will make you an upgrade offer. And the price of the upgrade offer depends on from which version you want to upgrade to the new latest version 4.5.
So next question. Previously, when deleting or removing a native frame from the project, the oblique images were removed too. Is this still the case? Yeah, so removing an image or the removing process that is related to the capture event. So it will be the nadir and oblique images combined for one shot position of the camera. So then, can the LAS 1.2 output be 4-band with infrared as intensity band? Right now we are exporting the data with LAS version 1.3. LES 1.3 supports 3 bands, so that can be used either for RGB or colored infrared. And for exporting 4-band texturing of the points, we require LES version 1.4. So when doing the export, this can be selected if doing the 3-band export or the 4-band export. So this question, are the obliques used for point cloud generation in the 3D mesh generation? Yes, so if oblique images are available in the project, then the software will definitely use the obliques together with the nadirs. If there is data only from a nadir camera, then we will use only that. So the software, UltraMap, is flexible. It will always take all the images that are available. And in that case, of course, using the obliques, yes. And then does the DSM generation use nadir and oblique images in the point matching? In the workflow for the DSM and auto production, so let's say the 2.5D workflow, the software is using the nadir images only for performance reasons. In the workflow for processing the 3D mesh and the point cloud from that path, the full 3D reconstruction of the data, the software is using both nadir and oblique images. And then what image types do UltraMap version 4.5 support? This software version supports all image data coming from UltraCam cameras. So starting with the first generation with UltraCam D, then the second generation with the UltraCam X and X Prime, to the third generation with the UltraCam Eagle, Falcon, and Osprey, we support data from all our cameras. And then the last question we have in this list, what is the temperature dependent modeling? Yeah, so this is a piece of software that we have implemented in our module for post-processing the raw image data. And this software is taking information from a temperature sensor that we have integrated in the camera. And this information of the temperature sensor is used to model the behavior of the camera. So during operation, there are some temperatures in the cameras which are different to the calibration temperatures. And this difference, this is used in the temperature dependent modeling to compensate there any changes of the various parts in our cameras. So the last question here, is it possible to use another coordinate system than UTM? Yes, of course. So the UTM system is the default system in the UltraMap workflow. But you're flexible to use any coordinates you like. So as long as the GPS data and the ground control points are consistent in a consistent coordinate system, you can process the data in that. So it can be any well-known coordinate system, or it could also be a user-defined coordinate system in a local definition.
Great, Bernhard, thank you very much. Good job, many questions. All right, so we see some other questions coming in. For example, OSGB. That feels like the question.
Yeah, the OSGB format is supported for the export from the 3D mesh. So the 3D mesh export, it allows to define map sheets. It allows to define a tile grid system for how you want to export the data. And OSGB is one of the formats that you can write for the 3D mesh. Yeah, so the question is if we can import shapefiles. Yeah, as we have a workflow with a lot of steps, the workflow allows a lot of things to do. This is a very general question. There are some steps in the workflow where a shapefile can be imported. Yes. For any details on that, to give a more detailed answer, I would invite you to send that question via email with a little bit of background, and we can discuss this. Yeah, and then we have one more question. Can we get a sample tile from 3D mesh from sample data of Melbourne to allow closer view and review? Yes, we can provide some sample data. So let's follow up via email on this, and then we will provide you with some data. Okay, more questions coming in. This is not UltraMap related, but related to the roadmap. So I hand over the microphone back to Alexander.
All right. So yes, there is a roadmap of new sensors. We are now changing. We are now doing an additional really huge step, and we are moving from third camera architecture to fourth camera architecture. That literally means everything will be new again. New lenses, new sensors, new electronics, new storage, new camera housing. And the first product which we will launch later this year is the UltraCam Osprey 4.1. And then subsequently we will change the whole UltraMap family towards the newer architecture over the next years.
Yeah, one more technical question. Which cameras has this temperature sensor? So all of our cameras do have a temperature sensor, with the difference that the older camera generations, they have one single sensor. And the newer cameras, that means the Eagles, Falcons, Osprey, they have a number of sensors, well distributed between the sensor, the electronics, and the lenses. So these sensors, temperature sensors, are at various points attached to critical components, so that we have a full picture of all the temperature changes that are going on in the camera. Yeah, question on a recorded version of this webinar. Yes, of course, we will provide a recorded version. You will get information on that later on via email. Then interesting question. Do you think real-time or near real-time extraction of ortho photography can be possible in the future? Well, that's a very good question. Real-time extraction, I'm not fully sure if I understand this in the correct way. Is this like a real-time processing of orthos, or is this extraction of information from that data? Yeah, right now in the near future, I think real-time or near real-time will be difficult, but then later on we will see. I'm happy to follow up on that question via email. So please send us your question and a little bit of background, then we can discuss that in more detail. So the first question is regarding the ortho pipeline. If you can import the boundary to Clipto or import tiles to Clipto. So right now we do not yet support that, but this is on our list to allow importing a polygon to Clip for all the data processing and then the exports. So the next question is related to the Typepoint collection, especially for the oblique cameras. So is there a suggestion for the size of oblique subset % and minimum image overlap for matching? Yeah, so the software is analyzing the data. So all the data in the project is checked for the image overlap, and then based on that, based on that, the software is then trying to calculate values, putting these values into the fields in the dialog window, and these are displayed for you. So in general, typically with all projects that we have tested so far, the default values calculated there are perfectly fine. But still, when checking the results, you are free to then rerun the Typepoint collection with modifying these values. Then we have here the next question related to the Typepoint thinning. Is it suggested that this function is applied before or after the bundle adjustment? If after, do you rerun the adjustment? When would you apply the Typepoint thinning? Yeah, so the workflow is flexible. You can run the Typepoint thinning directly after the Typepoint collection step, or you can run the Typepoint thinning after the bundle adjustment. So it is up to your preferences, up to your workflow, your requirements, how you do that. So from our side, we do not limit that in our way. We fully support a very flexible order of all the steps being done. Then the next question, yes, we will make this webinar available later on for you to view the recording. So the next question is then, is the DEM option available to export at this version? So this version, this UltraMap version, supports to export the DSM, the true orthophoto, and the traditional orthophoto, so the TM-based orthophoto. And the next major UltraMap software release we are working on, that will then allow to export the DTM. So then we have a question for the AT. What are the available export formats from the AT portion for use in other programs, such as ISAT? We provide a few export file formats for air triangulation data. So first we have the UltraMap EO file, exterior orientation file, where all the interior camera parameters are included, and the positions and angles of rotations of all photo centers. Then we allow an export of bingo project files, and we also support the exporting of Pad B files, so rotation matrices, plus additionally also camera definition files as being used, for example, in Datum Summit Evolution. Besides that, we export all the results from aero triangulation to the report that we briefly showed in the live demonstration. And this report is available on the one hand as a formatted document. On the other hand, we export that as a text file, which is machine readable. And all the other data from the bundle adjustment, all the residuals, all the image coordinates, all the 3D coordinates, all that is also available as text file exports to be used for further analysis or further processing. Yeah, then is there a quality assurance step available for processed auto imagery utilizing checkpoints? Yeah, in the auto application, you can import some points. So this could be ground control points, checkpoints, any X, Y, Z coordinates. And then these points are displayed. And the auto application also provides then a tool to read the coordinate values of any location and to read the height value, so that you can then easily compare the imported reference information to the data itself. And we have a question, how can I get this version, for which I will hand over the microphone to Alexander.
In general, there are two ways to get UltraMap. The first licensing model is a subscription module where you subscribe into the usage of the software for a certain period, usually several months, and you can select which UltraCam modules you want to have. And the next way to get UltraMap is a classical purchase option where you buy certain modules of UltraMap and you pay a purchase price for it. When you are under the subscription model, then any upgrade is included in the subscription fee. So just when a new version is launched, just ping us when you're ready to install it, and we will provide you with the new software. When you purchased a specific UltraMap version, then if you have a software maintenance contract with us, you will also get the software version as part of the software maintenance. Same procedure. When you're ready to install the new version, please ping us, you get the new version. When you have purchased the software without any software version, then please be so kind and contact your UltraCam sales representative, and he will provide you with an upgrade offer so that you can buy an upgrade to the latest version of UltraMap.
So the next question is then technical again. Are the oblique images used for DSM generation? If the project is captured with an eagle, is the resultant DSM quality expected to be lower? So we have two workflows, let's say, or two paths in our software. So the one is 2.5D processing. So that is the DSM and then the orthophoto production. For the 2.5D data products, the software is using the nadir images only for performance reasons. And then we have the other path in the software, which is 3D processing for the 3D mesh and the point cloud. And for that, we are using all image data that is available. That means nadir and oblique images. If the data set is from an UltraCam Eagle or from an X Prime, Falcon, from all these nadir cameras, then the workflow works in exactly the same way, but just using the nadir images that are available. So from a user interface perspective, there are not really any differences in between nadir and oblique processing, but the software in the background is checking automatically for the data that's available. So then the next question, are color and images improved by applying the AT and bundle adjustment first? Yes, so we highly recommend to first run error triangulation, including bundle adjustment and checking the results carefully to make sure that the orientation of the images in the block is as good as possible, because the color balancing heavily relies on the image orientations. So in this process of the color balancing, where we try to identify identical points in neighboring images, compare RGB values, and then try to optimize these RGB values across the block, a lot of processing depends on the orientation of the images. Therefore, this is very beneficial to the overall result to do error triangulation with bundle adjustment first. Then, how much, if any, DSM editing was done on the project shown? Yeah, so the DSM that we have seen for this dataset from Graz was not edited at all. So this was the result of fully automated processing. And then we have a question, are you planning to add any stereo module measurement for ground control points or manual points in the future? We get this question from time to time. Then we discussed that requirement. So it is not impossible that we do that in the future, still considering that. For now, we offer an interface to import ground control point measurements or any point measurements from stereo software into UltraMap. So there is a way how to integrate these measurements and then use them in the error triangulation workflow without any limitation. Yeah, then we have a question regarding Typepoint theming. Could you please describe a scenario in which you might want to use Typepoint theming? Yeah, so we get a lot of feedback from customers who had requirements from their clients to have specific numbers of type points in certain regions of the image. So there were very clear requirements on creating these sections for the image and then having there a maximum number of type points, not to use too many type points. So this is on the one hand related to weighting, to applying weights in the bundle adjustment, to not have too much type points so that they have a very dominant influence to the bundle adjustment result. On the other hand, this might also be related to some quality control issues. Then, is it possible to import LiDAR LAS files to use a surface model instead of using software generated DTM? Yes, for the DTM, we support the import of data from external sources. So the DTM ortho, the traditional orthophoto, that can be processed on any terrain surface that you provide and import into UltraMap. Then, are you planning to add DTM export function in the future? Yes, for sure. So we are working on that. A lot of tests are currently being done, and I cannot yet give an exact date for the release of that software version, but we definitely want to do that in the near future. And there will be a lot of exciting features around this functionality. So stay tuned and look for the upcoming release. Yeah, then will this webinar be available for viewing in future? Yes, so later on, we will send an email with guidance for where you can find the recording of this webinar. And then, does the improved Nadir and Oblique Image AT support 3D stereo view of all image data in one stereo photogrammetry project? Yes, so we can export all the data from UltraMap so that you can import images plus orientations plus camera definitions into a stereo software. It then depends on the stereo software if you can integrate all viewing directions into one project, or if you prefer to have separate projects for the viewing directions. Yeah, so we try to facilitate the setup of the stereo project with now adding the export of PAD-B files for all viewing directions, Nadir and Oblique, plus also the camera definition files, which can be used, for example, in Datum Summit Evolution directly. And then here one last question. Given the geometry of various lens focal length, will a non-oblique camera with a wider lens, shorter focal length, then produce higher quality models due to the parts of the image farther from the center being at a more oblique angle despite not being from an oblique capture? Yeah, interesting question. So there are pros and cons, I would say, to that. So a non-oblique camera might be interesting because of having certain characteristics with the field of view. But on the other hand, the oblique camera, it is fine-tuned in every single viewing direction to get the optimum there. So the oblique camera itself, it has the full photogrammetric nadir component, and it has the oblique camera cones looking in these 4 cardinal directions. And in all of these directions, it tries to get the optimum image content, which will be perfect for texturing the facades of the buildings and so on. Therefore, for an urban area, we consider the oblique camera to be there probably more efficient and give a little bit better quality. Okay, here a little bit more specific. This question more specifically, will the model quality differ between the different focal lengths available for the UltraCam Eagle? Yes, for sure. For the UltraCam Eagle, we have focal length ranging from 80 millimeter to 210 millimeter. So these focal lengths give a lot of different situations for the reconstruction of any 3D points. So yeah, given the concept of photogrammetry, this will then result in different model quality. So shorter focal length will give a little bit more details on the facades than the longer focal length. Then one question, for downstream oblique exploitation, will the EO be rotated properly if the oblique images are rotated upon export? So right now in this version, if the oblique images are rotated in export with 270 degrees clockwise or 90 degrees counterclockwise, this will then fit exactly to the export from the Bingo project or of the Part B files. If the images, the oblique images are rotated not at all, so 0 degree rotation, then this will fit exactly to the EO file export. So these are the combinations of image files and EO data that we typically see. So we try to make that as easy as possible, but we are working on a way how to handle that in a more flexible way to also support other use cases where other rotations might be required. One more question, is there a way to output roll, pitch and yaw for the AT adjusted EO? Currently we are exporting omega phi kappa, but we will add that to the list of ideas and consider that for future versions. And then we have a question regarding ACM and TDM. Are these parameters already embedded in the software project or require some input from the end user? Yeah, so ACM and TDM, these are 2 major components in the UltraMap workflow. So every single image that is processed from the raw level 0 to level 2 will undergo any of these 2 processing steps. So the 3rd generation cameras, they're processed with using ACM. 1st and 2nd generation cameras are processed with TDM. These 2 components of the software, they are applied fully automatically in the post-processing of the images. So there is no need for a user input to apply these to the images. So most important is that the cameras are up to date, let's say. So to have for the 3rd generation cameras, latest version of the hardware and camera calibration and camera operating software, then you can fully benefit of all the new features of ACM. All right, so this is a question for the image export. We sometimes use image software to make changes in the images after export. This removes the geoheader in the TIFF images. Do you have a way to put those back using a world file? Well, the image export supports that you apply both to the level 3 export. So on the one hand, you can do the GeoTIFF header for the TIFF files. On the other hand, you can do the world file. So both options can be activated when exporting images. And therefore, if any software for post-processing of the images is removing the GeoTIFF header, then you have still the world file existing. So is it recommended to import post-processed GPSMU to perform color balancing? I would say the color balancing is very flexible. It can work with or without the post-processed GPSMU data. It rather depends on the workflow and the workflow that you do. If the workflow is just for doing the processing of level 3 images and then exporting and using in other software for further processing, then you do not need any GPS data in UltraMap because then relative orientation of the block is perfectly fine for color balancing. However, if doing the full workflow in UltraMap, then you are running the error triangulation before the color balancing anyway, then you should have imported the GPS data already. And in general, if the GPS data is available, I would always import that because it will definitely help with the processing of images over water or over mountainous terrain with forest and such, where the extraction of type points might be a little bit difficult. Yeah, are the oblique type points weighted differently since they are further away? Yeah, so we try to take care of the various conditions, how type points are extracted and how type points are linked and connected within the project area. So we try to take care of that in the bundle adjustment. So there is a little bit of special treatment for all various groups of points in the dataset.
Is it possible to get a recording of a previous webinar that focused on the ortho pipeline and dense matcher? We did not have a webinar that was only focused on ortho pipeline and dense matcher. So the last time we did that was for UltraMap 4.0, I think. So we do not have that, although we might be able to help with other smaller videos that we created. So just shoot us an email, ask what you exactly need, what your questions are, and then we see what we can do for you.
And then a question for the Condor. Any word on when the Condor order workflow will be released? Yeah, so the UltraCam Condor is fully supported in this UltraMap version 4.5. So Condor data can be processed from AT to color balancing, DSM, DTM, ortho production. So all that is available. And as we then add new features for new releases, this will be more or less the same for all the cameras. So there is no limitation for the Condor processing right now.
So I would like to thank you very much for the attendance. I do hope that you found it valuable to attend the webinar. We joined it very much to share the latest news with you. We got an impressive audience and a ton of good questions. So thank you very much for joining the webinar, and thanks a lot for asking all these great questions. We are now closing the webinar. If anything else comes up in the future, please don't hesitate to contact us, to contact your sales rep via email. We are looking forward to continue the discussion. Thanks again and have a great day, great evening, wherever you are in this world.